Good day to you. This is Galactic on a Monday, July 28th, from Chico, California in 2025. Yesterday we had a video about the conjugate order where we were able to get up through the conjugalities discovered in subatomic space, whereby we now know and can prove easily what physics actually discovered in the 20th century and has never, ever been able to cope with in any way, except to make bombs. That's always good. And some crumbs fall off of the government table, so we get refrigerators, jets, cars, all kinds of nice things. Ever since the beginning of time, the highest goal of man has not been survival. The highest goal of man in all generations has been to understand the universe into which we are born. Why shouldn't we survive? Well, yes, we have two sides where we need to satisfy our physical needs in order to stay alive. I don't believe anybody argues with that. It's merely a question of priority, because you're going to die. And I told you there's going to be religion in every single one of my videos from now on, to remind you what science is for. It's not for refrigerators and bombs. It's to understand what the universe wants us to know about itself. Whether or not you're smart enough to realize that you have a designer that's so far more intelligent and more human than you'll ever be, then that's up to you to grow up whenever you're ready. But don't you ever let me catch you saying you're an atheist. Okay? Just so we're all friends. We're all in this together. We're trying to cooperate so we can communicate and share. Now, in the conjugate order, I am simply extrapolating on a very famous, although you may not have heard of it, don't worry, this is rather advanced stuff. But David Bohm figured out the quantum paradox. Although he never got the mathematical solution, I did. So that's what we're going to go into today, because you have to have the mathematical solution. Why? Because you have to prove your geometric solution, and that's what mathematics is for. Now, your mathematicians have completely forgotten that. There's a reason for that. They were bred. They're not really human. Mathematicians live in a separate universe that is divorced from reality. The reason David Bohm is so famous, really with religious leaders of the world, the ones that he met, Krishnamurti, Dalai Lama, loved this man. They loved him. He was lovable. From a very early age, David Bohm knew that the universe was holistic. He went into quantum mechanics because he thought that he was going to be able to improve the world. Well, he, like all men who are starry-eyed in their youth, simply following the natural dictates of heaven, get along with each other, be happy, and figure out how you got here. Well, you get disillusioned, you get beaten down by the harsh realities of the world, which will never be solved. That's Islam. It says in a surah, which I will paraphrase, basically the same thing Carl Jung said, that a man who is determined to be an idiot cannot be helped. You'll never get him out. Now, I believe, as most men believe, there's a footnote to that, because otherwise the prophets or wise men who visited this world would have had nothing to do. Well, they tried, and sometimes they succeeded, one would have to assume. But how you could prove that is beyond my ken. I am a religious man, so I do believe all that. Well, pity me then. But I do have a rational side. I know why I have it. I let it be turned on by the universe, and I kept going. I was a latecomer. I'm not very bright. That's why I didn't get into Stanford. So there's a little psychological background. Now what we're going to do now is pare this down because the conjugate order, we've already figured out most of it. We got it all. Not quite. Let's get rid of this part because we've already seen that. And let's expand this just a little bit. You might be able to see it better, but don't worry. I'm going to be going through it vocally. And let's make sure we can see all this. There's the universal reference frame. There's the quantum reference frame. And what are these nasty little symbols down here? That's the collapse of the wave function. So we're going to divide this into two parts so I can fulfill my promise to show you examples of linearity in the universe. Oh my goodness, yes, there is linearity in the universe. There are two major examples of linearity, one of which I discovered. Now, whenever you claim to have discovered something, I strongly recommend you hedge your bet a little. You may have discovered a new aspect of something that's already known. That can count as a bona fide discovery if it adds to our storehouse of knowledge, which includes structural insights and what we call understanding, explanations that make sense. If you're able to do that at any level where it had never been done before, well, you could very well say that you made a discovery. I don't think that's how we, spectators regard it. We want something wild with fireworks. Well, let's see if you agree that there are some things worth knowing that your physicists simply haven't discovered yet. The fact that I discovered these things, whether it's even true in any degree or not, who cares about me? I don't. Science doesn't. We want to know what the universe says, correct? Yes. So we want to know what the universe says. This is why I agree with Lori Gardy. There's really no reason to name anything in science after a man, because that doesn't explain anything. All right. So the conjugate order is my way of extrapolating on my hero, David Bohm, who wrote a book called The Implicate Order, and then he went on to discuss this with Krishnamurti, who literally thanked heaven that a man appeared who finally understood what Krishnamurti had been trying to say. So he got along famously with Krishnamurti. They had dozens of conversations, which I strongly recommend. Make sure you have some cold or warm beverage to drink, because these guys really get into it, okay? As you can imagine, with the greatest mathematician of the 20th century, who figured out the quantum mechanical paradox to a metaphysical level. Okay, well, that's where I step in, because David was using linear geometry. Well, we just went through, in yesterday's presentation, a fairly complete explanation of why linearity simply will not get the job done. It can't, because the line is an infinitesimal of the universe's idea of a line, which is a force, pressure. So it's a spherical line, but you have to now redefine line. We did not yet go back to discuss how Euclid misdefined the point as well. And that leads directly to the quantum framework. Because what is a point according to Euclid? Something with no length, breadth, or height. The three dimensions that they knew about. They just didn't call it 3D. They didn't have the word dimensionality. But they knew what they were talking about. When, for instance, Euclid says in the very first sentence of Elements that the point is axiomatically defined as that which has no length, height, or breadth. So it's not really there, so you might say, what a stupid definition. Well, yes and no, because it's superpositional, a word that you're going to come to understand very well. It's a very important term, superposition. It goes well beyond the superpositionality of state. It's a new form of logic from the point of view of legacy science. We've always used sequential logic. The universe does not use that. That's a derivative of what it actually does. There is sequentiality. We know that there's a time arrow we feel, and there's a space dimension we can also feel. Both of those are nonlinear. That's what we're going to dive into today. The conjugate order is meant to replace the word implicate with something geometric. The implicate order is structure at a very, very high level. And if you have never been exposed to David Bohm's implicate order, I can sum it up, but I'm going to have to be brief and stop on the spooky side, because it is spooky. It's the fact that in any context, such as, for instance, measurement. You've heard of the measurement problem. That's a big one. In any context in science where you're observing and measuring, which is what we do to get our proofs, you have layers of order. And you're trying to operate at the superficial order essentially to get a linear solution, which is redundant. You need numbers to prove your geometric insight, which is how you understand things. You don't understand things with numbers. That's a mistake to think that. You could say it on an extrapolation, but you're missing something. You're missing geometry. Geometry is how we see things. It's not constrained to an exact duplication of what we see in physical space. We're able to do constructions in our visual perceptual system, which is an onboard system. It's kind of like a blackboard that you can draw in. Well, you can do all kinds of things in there and try to match what you see in your head with what you see in reality. Well, when you go to measure, there may not be an exact match. That's the case in quantum mechanics. There's no match between what we see and what we can understand. I will now show you how you can see what we've never understood. And then it's up to you to understand it. You have to synthesize it. It will always come down to you. And that gives you freedom of choice. You don't have to accept anything against your will. If you refuse to see, it could be because I presented it either badly or poorly or not well enough for you to get it, because it's really difficult to know where the latch will be. A good presenter tries to make this accessible to anyone. That has been my goal. I hope I'm getting better at least. So let's start with a conjugate order. It's a depth order. And an order implies hierarchy. So when you're doing a measurement, you may not be aware of suborders that are happening that you're unaware of because you can't perceive them. Well, at the limit of human visibility, with or without instrumentation, in this case with, obviously, you may not be able to actually correlate what's happening such that you can prove it with what's happening. You can't prove what's happening anymore because something's happening that you simply can't see. Well, I want you to think about that for a second. What would be the obvious framework for solution if what is happening can always be narrowed down to it's invisible to you? It could be because there's an invisible aspect to the universe. But that's relative. If it's in the universe, it's not invisible. But it might be invisible at our level of understanding. Well, we're quite new to the universe. We didn't know about galactic space until exactly a century ago. That's not very long. So we haven't had time to mull it over, but Einstein really threw a wrench into the works. This is not to denigrate his work. He made one of the greatest insights of all time. But you see, he used linear algebra to get the solution. So there is a hole in general relativity. It's called a singularity. So let's begin with the singularity. You may have heard of the singularity. It has several definitions because it's a overwhelmingly powerful, ubiquitous phenomenon in mathematical science. The singularity is a center that can be shown mathematically to invert. And you may remember from inversive geometry that is tricky. And here's how it works. In what is called a supermassive black hole, which I know you've heard of because you're not allowed to exist unless you know that you're from a monkey, which is a lie, that the universe is expanding, which is a lie, and you also have to know that the singularity inverts. In other words, it sucks space in, which is now construed to be space-time. So the supermassive black hole is hypergravitational, the way it's computed. So according to the mathematics, this supermassive black hole must have a singularity, which means the center, but it's not a Euclidean center. And so physics disappears at the center of the supermassive black hole. That's called psychosis. If you actually believe that, and now you work off of that observation, we've proved that the universe turns inside out, then your mind has turned inside out, and you're now useless, and you're actually dangerous. And that's what they all are. They don't care, and we don't need to go into why they don't care. They're funded by the government, so they're protected. So now they think they're gods. So now the new atheism is emerging, and it's up to you and me to withstand it. I don't recommend withstanding it overtly. They'll kill you, metaphorically speaking. If they could actually kill you, they would. They can't yet. But history isn't over yet. We already know there's a murderous terrorist force at large in the world, which has already won. We've entered the apocalyptic age. I warned you. You're going to get this. You don't like it? Get out! Okay, this is science. So if you're a big boy, you can stay. But you're not going to argue with me. Physical linearity. I have selected two examples of why Euclidean geometry might be found in the universe. What are the two examples? Well, one of them I have labeled here, the polyhedral web. You may have heard that at the highest scale thus discovered, with at least 20 footnotes, because we haven't discovered everything. I'll get into that as well, so you know the absolute spooky side. What does the universe actually look like? We're not quite sure. Because of quasars, quasar groups, and macrostructure that cannot possibly have come from a Big Bang. That's known. They'll never stop saying the Big Bang is true. They can't, or they'll lose their money. That's how it works. You can call it communism or free, you can call it whatever you want. These men are not free to think anymore. You must follow the lying model. So there is a singularity, whether it's true or not. What I'm going to do is show you what the singularity actually is. And one way to find that out is by examining the macro scale structure of the universe. There are, so far, discovered in the universe, given a correct axiomatic definition of a cosmic unit, what would that be? Maybe a planet? That's a unit. What about a star? Yes, that is a cosmic unit, the smallest. Why? Why would not a planet be the smallest cosmic unit? Well, it could be if you axiomatize your system down to the planet. We don't need to, because the planets will be in the system. But we're talking about luminous objects. Luminous. They're on fire. Every star is a thermonuclear holocaust. It's really an amazing phenomenon. A ball of very hot plasma, correct? Sending out an enormous amount of radiation that floods the Earth, for instance, at the ideal distance from the sun, given our size, our tilt, is actually a work of genius of the great creator. And if you don't know that, I pity you. You just think it was an accident. Well, you can go talk with a physicist. They would love to have you for lunch. But I deal only with truth. So the smallest luminous object in the universe is the star, cosmic unit number 1. What's the next cosmic unit? That was essentially officially discovered exactly 1 century ago. 1926 is the usual date, but it's a little hard to pinpoint. But Edwin Powell Hubble, the famous major that had just come back from defending the United States by fighting the Krauts in France, that really helped defend the United States. So many of our men died in that hellhole. But Edwin Powell Hubble came back, and since he was an astronomer, he was able to pilot, as I like to put it. It's hard work. But he manned the Mount Wilson telescope. He got a fix on some stars in Andromeda and proved that Andromeda is about 1,000,000 times further away than anybody had ever suspected. It's not part of our star system. It's a separate star system. Very shortly thereafter, it was confirmed what men had already discovered but had been unable to conclusively prove, that we are in a galaxy, which we call the Milky Way. Andromeda is called Andromeda. Those are 2 separate cosmic units at galactic scale. We no longer call them nebulae, because they're not just fuzzy. We can see them now. They're galaxies. And the universe is made of stars? Yes. Although that's an incomplete statement. Is it made of galaxies? Yes. And all stars are in galaxies. That was debated for a while. It was uncertain. Perhaps stars exist outside of galaxies. Never. There is no star that's not in a galaxy. So that's cosmic unit number 2. My own teacher, my beloved teacher Fritz Zwicky, who was blackballed because he wouldn't go along with the Big Bang, he called his fellow astrophysicists spherical bastards. I do too. You can't go against a thinker like Zwicky and get away with it. You may for a few decades, but someone like myself will come along to resurrect his name. His work was not lost, but he discovered the 3rd cosmic unit. You may not know that. What do you think it is? Perhaps a cluster of galaxies? You are correct. That is the 3rd cosmic unit. Are there any galaxies that are not in clusters? No. The same is for stars and galaxies. All stars are in galaxies. All galaxies are in clusters. Zwicky studied these more than any other man, ever. And he made the world's first catalogs of these objects, including the Coma cluster, one of the nearest clusters to us. These are clusters of galaxies composed about evenly of spherical galaxies, usually called ellipticals, which are kind of dull, roundish galaxies filled with mostly red stars. But then there are the beautiful spiral galaxies, which it has been computed now fairly accurately. About 45% of all galaxies are spirals, generally speaking composed of blue-white giants, making them unbelievably beautiful. I fully believe they are the most beautiful objects we'll ever see in this universe, but that's saying a lot. Take that with a grain of salt. There's a lot to see, and we haven't seen it all, and we're getting to the best part. So that's the 3rd cosmic unit, and that is the building block of the next cosmic unit. But the next cosmic unit is different from the first 3, because a star is isolated from other stars. Galaxies are isolated from other galaxies. Galaxy clusters, which are composed of about, on the average, about 300 to 1,000 galaxies. Typical size, they have a standard size. It's within a certain range. Those are the largest independent units. So you could say there are only 3 cosmic units at the basis of the universe. Stars, which are all in galaxies, which are all in clusters. So it's perfectly appropriate to say, if you know what you're saying, that the universe is composed of galaxy clusters as building blocks. Do they form a higher structure? Yes, they do. They form exactly one more that's been proved. But I'll show you there is another that I believe has been proved. It's just that the modelers don't like it. So the next highest unit is the polyhedral web. The galaxy clusters, when they're seen in perspective, which means you have to get a wide field series of photographs of the sky at high resolution in order to see the greater structure, it's like backing up so you can see more of what's in front of you. Always look behind you before you back up, by the way. You don't want to back up off a cliff, or you'll see more than you wanted to. So, but in general, that it's a matter of perspective. If you go backwards to see more of the universe, you will. The thing that you're looking at will get smaller, but in context, you'll see where it is. Well, where are the galaxy clusters? They form a structure which was first thought to be superclusters, because they do form more massive groups where the clusters are clustered. But on closer inspection, that brings us about up to this millennium, it was discovered that these groups of clusters are connected by linear strands. Linear. That, you know what that implies if you remember how we discussed linearity, but we're getting to it. We're going to cover it in more detail. What does that mean that it's linear? Didn't I just say that everything in the universe is spherical? We discovered that in the 20th century. From the smallest scale to the largest scale, everything is spherical. Don't forget I also said it's superpositional. Because in electrodynamics, and only in electrodynamics, you find a linear feature called electrocurrent. A current of electricity goes in one direction on a line, in a wire or a circuit. It goes in a straight line. Now that line can be bent, but essentially it's going in a series of straight lines. It's not going spherically. It's being channeled. And as it's being channeled, it creates a toroidal magnetic field around it. Watch a video by Veritasium, one of the best presenters, although you have to be careful what these men say because they're all industrial scientists. They want the approval of the industry, so they get money, usually from YouTube in this case. But Veritasium is very good, extremely good. And he has a video showing that whenever there's electricity flowing through a wire, such as in your street, way up on the telephone poles, those wires strung, there's electricity going through there. Well, there's also a magnetic field around it. And you got to see that video so you'll see the relationship between linear electroforce and the conjugate force of magnetoforce that always occur together. All right. So that's where linearity enters in. It's in the channeling of electroforce. Can we find that at universal or cosmic scale in one of the cosmic scales? We certainly can. We see it at all scales. And I'll show that to you now. But at the highest structure that we found so far, that the James Webb telescope cannot invalidate this, the structure is constant. It's called homogeneity. It's one of the basic principles that the universe is not lopsided. it's the same in all directions in terms of the distribution of matter. Statistically, that has been proved conclusively. Almost. There's always a little doubt because we haven't seen everything. But at the highest scale, if you were to envision the entire universe just using your visual perceptual space and the narrow waveband of light that we can see, you would see that the universe is a giant web. And it looks like this. It has a kind of a spherical, you could say that's reasonable, a spherical concentration of galaxy clusters. But the galaxy clusters, if you back away, you'll see that there are strands going out from these nexal points. And if you follow the strand, it goes to another, what used to be called a supercluster. You could still say that, but they're no longer independent. They're all connected. They're all connected. It's one unit. Now, there's more beyond that, and we're getting to it, but that is what is known so far. In context, that is the structure of the universe. It is clusters of galaxies strung together like beads into polyhedra, and a polyhedron, you may know that the simplest is the tetrahedron. There's cubes. There are other shapes, but their volume on a plane, you don't call them polyhedra, you call them polygons. So they're volumetric polygons. That's called a polyhedron. You may know that there are 5 Platonic polyhedra, and the definition of one of those is very interesting to look up. I recommend it. It's easy to understand, but you do need to get a good definition. But those are polyhedra. Now these make shapes with a void inside. So they're polyhedra with voids inside. They're not empty, but they're virtually empty. They're very sparse. The clusters of galaxies are arranged in this way so that they look like they're connected like a giant spider web. And it's been called by many names, soap bubbles, a sponge. I think a sponge, if you've seen a close-up of the structure of a sponge, it has the same polyhedral arrangement, where there are nexal points, which are points of strength. Sponges can be extremely strong. In fact, if you've never heard of the glass sponge, I'm going to tell you a story that blows the mind of anybody. Some people don't even believe me. They have to look this up because it sounds too crazy. In Japan, when they get married, very often it's just a common thing that's done in Japan. A gift will be made, I believe it's to the bride, of a glass sponge. And you can look this up. I strongly recommend you take a look. Just type it into your search engine, glass sponge, and click on images, and you may not come down for a long time. They are incredibly beautiful. They're incredibly strong, but they're sponges, and they weave glass so strong that scientific engineers have studied these with grants, if they can get them, of course, because you need a grant. But it's worthwhile to the government that certain men who are interested in the structure of glass sponges study that so they can make better weapons. My God! You have a lighter casing for a thermonuclear explosion over Jerusalem? That would solve a lot of problems, but I don't think that's exactly what's going to happen. But it's nice to imagine. It's not, because it would kill some Muslim people. You don't want that. I'm quite biased against the aggressors, yes. I don't care if if my country supports them. That's not my country doing that. It's some invader, some parasite who got a hold of my country. Well, they've gotten hold of every country, so we're not alone. They got hold of Russia very quickly. And now they're attacking Iran, their ancient enemy. Well, the United States is just a bunch of you-know-whats. And I don't go along with it. No. You're not going to get away with bombing Iran. You just started the apocalypse. And now you have a two-front war because you're NATO, because you're New York. I wonder who lives there. And you own the world. You own all the banks. You tell all Americans what to do and they just kiss your you-know-what. Well, I'm sorry, I'm a religious man. I don't care if you're atheists or not. I don't care if you're Zionists. You're not getting away with anything. There's going to be a judgment and you're going to get it. But before that, we're all going to get it. That's called the apocalypse. We're in it. All right. So the polyhedral web is a giant glass sponge made of balls of fire. It's true. So is there anything else? I would like you first to just cogitate something. Why is that linear? Polyhedral means linear. It's not spherical. It's linear. What caused that? Electromagnetism caused that. So now you know how the universe was formed. It was formed from electromagnetism. Or there wouldn't be a web of polyhedra. Because those strands represent explosions. They're explosions. And now I'm going to show that to you so you'll be one of the first humans to ever understand what is a supermassive black hole. Nobody knows what that thing is. I do. So we're going to talk about that now. But the way we're going to talk about it, I think you're going to like a little visual imagery. That's always good. Let's stimulate our visual perceptual space with what the universe says, not what this little man says. Okay, there's our introduction to outer space. That's the first thing a child sees in its lifetime. That's a cosmic unit, although not by our previous definition. But it is a cosmic unit that is not on fire. It's made of dark matter. We're getting to that too. One of the discoveries of my teacher, Fritz Vicky, was dark matter, dunkle materie. But that's a little portal on the moon. There we have the Pleiades star cluster, one of the brightest stars being seen in that cluster. The whole thing would fill this page. But we're dialing out. We're now looking light years away. Now that we've had a brief review of the macro structure of the universe, including the so-called singularity at the center of the so-called supermassive black hole, we can now go on and complete our tour of the conjugate order, which is simply the orthogonality built into physics. You've seen two examples of linearity. The polyhedral web is linear due to explosions creating everything else. And then there are smaller explosions creating galaxies. And then there are, actually, we know this now, stars do this too. In fact, that's how the black hole was discovered. So stars are born from explosions also. So everything is born from explosions. Is accretion operative anywhere? We're almost certain, although I'm not sure anyone can say we're absolutely certain, solar systems apparently formed by accretion. There's no other way to describe it. So we're fairly confident of that. But as for galaxies forming by accretion, no, they don't. They do not form by accretion. They form by explosion. And you just saw it. So whether you accept that or not is entirely up to you. If I didn't reach you, it's either my fault or I'm wrong, or you aren't ready or willing, whatever. But we're still free. We don't bow to anybody except the universe, okay? All right, so we've seen the polyhedral web and the cosmic jets. Now, the conjugation of infinity is probably my greatest discovery in a certain sense. I will have diagrams for this, but I don't want you to see the diagrams right now. You've seen the conjugation of infinity. In the Boscovich force curve, the quantum at the center of the atom is composed of two quanta that are conjugated, called the electrophenomenon. Basically, the electron or the photon, those are non-spatial particles. Certainly the photon is non-spatial. The electron is partially spatial, but only the proton is spatial. How do we know that? It makes a position. And it uses two forces, the centripetal force, beyond which it inverts and becomes centripetal, to attract protons because they're conjugal. And when an electron comes into a proton and reaches that limit where the force field inverts, it goes at a right angle into a spherical standing wave. That's a wave. It's no longer a particle, it's a wave. It's not a particle, it's a wave. The particle turned into a wave. What was it before it was a wave? It was a wave. And that's called the wave equation of the electron. So, the proton is a space particle, the electron is not. All right, we would not know about either of those particles if they didn't conjugate and define each other. And now you know the force balance of universal reference frame, but there's a problem with universal reference frame, which Einstein was never able to achieve. He had a special reference frame, zero, a singularity. Then he generalized it to a general reference frame, still zero, so still a singularity. No answer to the monopolar aspect of gravity. Now you're going to see it. The conjugation of infinity. What does that mean? Is the universe infinite? You could say yes, you could say no, but it definitely has what appears to us to be an infinite edge. There's a model that says that it does not have that edge because that edge is the Big Bang. That's incorrect. No, it's not. But they do have a certain, you can't throw that theory out. Nobody knows how the universe originated. That's ridiculous. We'll never know that. But we have to try. We're blueprinted to try. So I don't say that that's evil. It's just that in science, if you have a theory that turns into a model, which is simply a bunch of theories that you think must go together, well, what happens then is, after a couple of generations of that dominating research, pretty soon they just say, well, then it's a law. Because we've been studying it, we're getting paid to study it, therefore it's true, and nothing else can be true. That's not science, that's superstition. All right, so the conjugation of infinity implies there's two infinities. Well, of course there are. The one that every child learns about, the one that we guess about, what's at the edge of the universe? Well, if we had the words for it at our single-digit age, we might have been able to say it's imaginary. And that's correct. That is the characteristic of infinity. It cannot be imagined, and therefore you have to use your imagination just to know that you can't. Your imagination doesn't work. Because it's a contradiction. If there is an edge, that immediately implies there's something beyond the edge. That's called the outer product in geometric algebra. And it's compensated by the inner product. And that's called the geometric product. The, to date, best formulation of linear mathematics is in geometric algebra that I studied for years. All right. You can look it up. You can study it yourself. You won't get far. It's one of the hardest conceptions that the human mind can ever try to figure out. But it works. And I studied it until, I'll just say, I understood it to a threshold that's hard to reach. And that is the conjugation of the outer product, which you can think of as spatial infinity. This is a metaphor. And what's at the center of an edgeless universe. There's no center. If there's no edge, there's no center. Is that absolutely proved? No. No, nobody can say that that's absolutely true, because we cannot imagine it. But we've discovered both edges. The James Webb Telescope is proved to a brand new threshold. The universe is infinite. Is it? No, it can't be. You know why it can't be? Because of Olber's paradox is one thing. If it were infinite, it would be completely filled with light. That's called Olber's paradox. The cosmologists think they've solved that because if the universe is expanding, then there will always be an increasing gap between the stars, which, if there is a Big Bang, then the universe is not infinite. And also, it can't be infinite anyway, Big Bang or not. By the way, what's the true meaning of the Big Bang? Which is thought to have been proved mathematically. What they actually proved is that the universe is rotating. And that also solves Olber's paradox. That's why the night sky is dark. But there's another direct perception of why the universe cannot be infinite. Do you know what it is? If it were infinite, it would be incomputable. But it is computable. Therefore, it's not infinite. Instead, it's hyperspheric. We cannot see beyond. When we see spherically, we're only seeing space. But you know there's also time, and that's non-spatial. So the true conjugation of universal space to get the universal reference frame would have to take account of the edgeless edge. We call that spherical infinity. It's one infinity. It's what's beyond the finite universe. That will blow your mind because it doesn't conform to linear logic. Well, the universe is bigger and brighter, and is smarter, older, faster, fancier, jollier, happier, realer than we can yet see as little tiny larvae on this God-cursed planet that's about to destroy itself. And if you're interested in religion, you might get some answers. Eventually, I'll force those fucking answers down your throat because you're too stupid to wake up. But there is a reason for everything, including evil. Okay? Or what happens to Hitler, darling? All right. Think about that when you have a chance and you're not, playing your video game. Okay? You have plenty of time for that. Try spending some time waking up. That's why we have science. It's also why we have the ancient records meticulously handed down and probably corrupted. We have enough information to know how we originated as humans. You don't want that? You're not a scientist. You haven't grown up. I'm trying to be compassionate, but we're running out of time. It's a good thing you're tuned in, listening to Anagalactic. Thank you. It means a lot to me. All right. So the conjugation of infinity will be to mathematically correlate the imaginary edge with the imaginary center. We already know what the center is. In space, right? It's the proton. Because the proton makes space. Because of its centrifugal force, it makes a position, it has a radius, and it has something outside, which is a centripetal force that the electrons feel, but the photons don't. So the photon is a transitional particle between two domains. So when a photon detaches from an electron shell and goes free, it doesn't have velocity. Where did it get its velocity from? No. It's falling. It's in free fall. This is what Einstein could not see. He just couldn't see it. That the photon is falling. It's going out. It's going out from wherever it departed from. It's falling to the edge of the universe. Just exactly the opposite of space falling into the proton, where it's contracted to a black hole. Every proton, it defies physics. Well, that's the basis of the universe. Something has to be axiomatic in the universe. It's the proton, but the proton isn't alone. There's a transitional particle called the electron. Well, actually, the electron is a particle, but it's the antiparticle to the proton. Now, you may have heard that Paul Dirac predicted the positron, which is the charge opposite of the electron. And I would have to credit that. It was predicted by Paul, and then it was discovered. There is such a thing as a positron. But it's very strange, and if you wanted to look into that, you won't be able to because it's part of the standard model. They'll have you for lunch and you'll go insane. So I caution you away from the standard model of particle physics. They're out of their minds. And I've given several lectures on that, but I don't like to be negative. I'm not here to pull down pillars. I'm here to show you what the universe says. All right, so there are two particles and only two. Is the photon a particle? I'll now show you that it is. But it's not like anything you've ever heard of. And you would expect so because your physicists cannot understand it. They simply can't. I mean, you can go around Robin Hood's barn for centuries, but they're never going to get it. I'll show you what it is. By showing you the solution to the collapse of the wave function for the first time in scientific history. So Einstein wanted the universal reference frame. What would that imply? It would mean that he had found the center of the universe. But you and I know that in order to find that, you're going to have to find it at the quantum level because you're talking about the center of something. There's only one center we've ever found. It's the proton. That's the only center of anything. It makes its own center, you understand. The centrifugal force makes its radius, and on the other side is a reciprocal force, so that it's a harmonic. It's balanced. Is it? It's pulling space in, right? We know that that's what gravity does. Kepler analyzed it, Newton analyzed it, Einstein analyzed it. Gravity affects space. Now we say that gravity affects space-time. That's incorrect. I'll show you why. So the universal reference frame is the proton, but that's incomplete. Now we know the center. Then what's the edge? Well, we know it's a spherical frame of reference. So it does have a spherical center. And I proved to you that the non-Euclidean point has a surface. It's not 0D. There's no such thing as zero. That's very important, that there's no such thing as nullity. There's no null anything anywhere, either in mathematics, except for distance. But that's on a line which is a derivative. You have to have zero for distance. You have nowhere to cut off the line to get the distance in the positive direction. So zero works for add. We add the units to the star, or whatever we're getting the distance, the single component number. But light speed is a two-component number. It's a relationship between what and what. We say it's a relationship between space and time. Einstein proved that is a correct derivative solution. It enables spaceflight. So it serves Satan right up his ass. Satan is in outer space now. And whatever you think Satan is up to you, but that's the right name for the thing. It's a group mind. It's inhuman. It's a composite of men's minds, obviously dominated by a supernatural mind. So Satan needed to get into outer space. Well, he did. He also needed to bring Israel back on the map. He did that at the same time. Correct? You figure it out. But I'll continue to tell you and warn you what's happening. Science is commandeered by an evil power, of course. Where do you think we got the goddamned atomic bomb from? Altruism? The opposite! Okay, that's enough. Don't push me. I try to be jolly, but I'm also dead serious because... okay. So the universal reference frame is the central surface, which is a sphere. It's the quantum sphere. It's the radius of the proton. That's the frame of reference. But they're everywhere. Literally, protons are everywhere. Well, each one of them is the center of hyperspheric space. Obviously. That's tautological. So now we're in non-Euclidean spherical geometry, which is transcendental. It's the conjugation of two spherical realities, only one of which we'll ever see. But we've discovered the other one, and we cannot figure it out because your scientists don't know how to conjugate. There's a relationship that makes the quantum phenomenon, and it's a fixed structural relationship between two forces. And that will explain everything because it's relational, not Euclidean. You have to use a single component number to do Euclidean mathematics. The universe only uses two-component number system, binary. The dyadic fractions, 2 over 1 to infinity over 1. So the edge of the universe has a number. It's an imaginary number, infinity over 1. Well, what's the reciprocal? The reciprocal is the conjugal, because they multiply to the surface. So the edge of the universe is infinity over 1, which is imaginary. Perfect. So we know the center. It's 1 over infinity. And so the radius of the proton is 1 over infinity. Is it? No, because it's finite. So what we're doing is we're getting the universal frame of reference that Einstein simply couldn't figure out. It's imaginary. That doesn't mean it's not real. It's actually super real. And super real is the same thing as imaginary, because you cannot conceive it. But it's there. The edge of the universe is finite, but you can't get rid of what's beyond it. So we give it a number. Lazy 8, spherical infinity. Imaginary. How is it defined? It's higher than any other spherical number, which means you can't use it, because it's imaginary. But it has a use in imaginary space. It's reciprocal to the center. So now we have the center and the edge of universal space. And that's the reference frame. What is the number for the reference frame? Well, multiply infinity over 1 times 1 over infinity. That's the conjugal relation in spherical space. What does it multiply to? What does it multiply? You don't want to say 2 because that's a number. What does it multiply out as? 1. It's 1 proportion 1. Well, that's light speed. It's 1 proportion 1 when it's unitized. That's done all the time. If you make light speed 1 proportion 1, you can do your mathematics a lot easier. Trust me, it's a lot easier than saying light speed per second. That's a strange number, although it's the most constant number we know. Although that's being debated, and rightly so, by men like Unziker. There's no way that light speed is constant, because it doesn't have a speed. What it has is an effective rotation, because as light falls, a photon detaches and falls to the edge of the universe. Is it a particle? I'll show you that it is. But it's going to expand your mind into the 4th dimension. Well, you have to. Einstein said that's what we have to do. He himself could not do it because he thought that Euclidean mathematics works. He should have known better. There's a 0 for the reference frame. Incorrect. The reference frame is 1. The surface of the smallest thing in the universe has a surface value of 1 proportion 1. Okay? The electron-proton relationship proves that because it's fixed. The electron always is at the same radial distance from the center of the proton. It never changes. So that's the quantum, both of gravity and where the electron is on the surface of the proton at the limit of the force inversion. The electron occupies the inversion so that it's equal. So it's locked between two infinities. That's the electron shell. It's quantized, but you have to define what you mean by quantized. It's not quantized in linear space. That's why they can't measure it, because it goes in between the numbers. And Cantor could not fix that, because linear mathematics is quantized. You can't have a number between 0 and 1 if the distance from 0 to 1 is the smallest measurable distance. That's been proved. It's called the Planck length. Well, there's also a Planck sphere that the proton makes. A Planck sphere. It's the smallest indivisible unit, is a proton. So what's at the edge if the proton is at the center? Well, if you say that the proton has no interior, you're not saying it has no interior. You're saying it doesn't have a computable interior. Well, that's imaginary. If you can't compute it, it means you can't measure it. That's why you can't compute it. You can't compute what you can't measure. Yes, you can if you remember geometry. Oh, they've all forgotten geometry. They don't need it. They're gods with their linear numbers. Well, they're devils, too. So you know where they're at. You do not want to be where they're at, or you'll never speak the language of the universe. I will teach you that language. That's an hour. I will wrap this up with a definition of the collapse of the wave function that I hope you never forget. I hope I do this well. I've tried a few times before. I think I did well enough, but there's always room for improvement if you're breaking the bounds of physics into a new domain of understanding that solves all the paradoxes at all scales, because now you're using the right mathematics, because you're using the right geometry. Spherical, two-component numbers, no more linear Euclidean blindness. The ability to have supervision, and the universe wants you to do this. If you can, you'll be rewarded. Understanding is a reward. Get it with all your strength, get it with all your might, sell everything you own to get wisdom. You can't get wisdom without getting understanding first. And there is a transitional stage between understanding and wisdom. It's called tibuna, which correctly translated, I am a Bible scholar, it's a word from Proverbs. There's bin and binah, knowledge and understanding, and then there's tibuna, synthesis. And if you can do that, you can go on to the highest, wisdom. And that'll solve your bind. It'll blow your mind and undo your bind, according to the merry pranksters. Oh yes, it will. And you'll never need LSD again. Okay, so what is the universal reference frame? Well, it's the proton and the edge of space. And we just conjugated them. It makes a surface of 1. Now, what is the quantum reference frame? Isn't that what we just defined? Yes, we defined the quantum reference frame. The smallest surface is a proton. So that's the quantum of gravity. What about the electron? It's conjugal, so it's non-spatial. It's pure motion. It's nothing but a wave. That's what motion is, a wave. Everything that moves is based on wave mechanics, not in macrospace. That's what confuses your physicists. It's just like they're back with sticks drawing in the sand with Euclid. They can't see a thing. because they haven't evolved. The only way to evolve is in your mind, to conform with the universe. Isn't that evolution? Yeah. So you're doing it now. So here's what happens when a wave departs from its electronic surface. It detaches by an evolute, which is the Boscovich force curve. It curves off. There's no quantum jump. It curves out and then falls. So it's a falling piece of energy. It's an energy packet that's in another domain that you'll never see. But Christian Huygens proved that it's a spherical wave front. That is known. When it arrives at your telescope, which it must do, because it's going to intersect with everything in the universe before it reaches the edge. Is it a particle? Yes. And here's how we know it's a particle. It detached as a particle. It's going through space as a particle. But according to our linear mathematics, that's an expanding sphere. You would have to say so, but it's not expanding the way you would think. It's not changing its volume. It's not in space. It's partially in space. It's conjugate with space. But the part of it that is not in space, that is conjugate with space, is that wave. And that's superpositional entanglement. The photon is a particle that exists everywhere on the surface at the same time. It was Sir Roger Penrose that pointed out that a photon does not experience time. It's because it's exhibiting what time does. It goes at the speed of time. Time has a speed. Time has a speed. The photon does not. It's just falling. It's in its own inertial frame of reference that has nothing to do with space. But it does. And we know that because it finally arrives. Then we compute the linear distance back and wonder why the wave collapsed. It didn't collapse. That sphere is a particle. It has no radius. It's just a falling particle in all directions. And when the particle reaches your telescope or your eye, it is that particle, because it's a particle everywhere. That's superpositional coordination. And the information is retained. That's a miracle. The miracle of light. And it doesn't collapse. It simply arrives through another domain that you cannot see or imagine. You've got to imagine it. I'll show you how. Thank you for tuning in. It means so much to me to know that somebody's listening. All my life, I've tried to teach wisdom. Very few people want it. I found a few in Ukraine. I was well received in Kiev. I was well received in Yalta. I was not well received here in any church. I was sidelined because I went against their goddamn doctrines. So whatever I said about the Sabbath, the fourth commandment, or the name of God, the third commandment, they didn't want to hear. You judge whether they're really religious or not. They might be, but they're on the wrong side of the religion fence. Just as in science, so in wisdom, you have to be teachable. It's a risk. You can go back to your playpen anytime you want. Not with me, you won't. Thank you for tuning in. Blessed art thou. And I invoke the blessing of Allah. As a finite mortal, it's the most I can do, and I'm allowed to do that. May Allah bless you with whatever you need. I hope to supply you with your deepest need, is to be unified with the universe, so that you'll understand your Creator. Obviously, your Creator loves you. Do you believe that? I don't care. But I hope you do. Stay tuned, we'll have a lot more. This is just the beginning of a new age of science as the world is about to destroy itself. Isn't it fun? It's like being on a roller coaster ride that's the most funnest thing you've ever been on, but it explodes at the end. I couldn't think of a better game. I hope you're a winner. I'll try to help you be the winner that God wants you to be. May Allah bless you.